Okay, sorry. For the first part of this essay question, is asking to compare and contrast the sympathetic division of the ANS and the parasympathetic division of the ANS and the somatic nervous system. So first thing, we're gonna do the sympathetic of ANS. It's also asking for the origin, number of neurons, and location of ganglia, and a few other things. So first thing, the origin, it is where the thoracic and lumbar regions of the spinal cord are. So basically this is the spine, right? And then this is the lumbar. Am I saying it right? And then this is the thoracic. I don't know. So it's basically talking about the space in between this. So that's where the origin is. And then for the number of neurons, they're still talking about the sympathetic. It's two neurons. The two neurons. It's pre and post ganglionic neurons. So basically what this does, it connects the SNS to the effector organs. So the preganglionic neuron carries the nerve impulse from the central nervous system to the ganglion, and the post neuron carries impulses from the ganglion to the smooth muscles or gland. Like an example would be like the heart, and a ganglion is just, I believe, a collection of neurons. And so the location I don't know how to spell of ganglia. That is near the spinal column. So there's the sympathetic chain and the collateral ganglia. So and then collateral. So sympathetic, it's alongside. I don't know how to spell. The spinal cord. And then this is near the abdominal arteries. And then neurotransmitter. It's the preganglionic neurons release acetylcholase, and the postganglionic neurons usually release norepinephrine. So pre equals releases, and then post releases norepinephrine. That. And the types of receptors are adrenergic receptors, alpha and beta, which adrenergic basically it goes flight or fight. And then some of the actions that it does, it prepares the body. Oh yeah, fight or flight. It prepares the body for flight or fight responses. So what it does, it increases heart rate. We see dilated pupils and digestion stops, but we don't see that. Okay, so there's that. I'm gonna erase all this now. And then for the parasympathetic division of the why is that? Oh, what the? Fine, let's just delete this. Oh, it does not want to go away. That is crazy. Okay, anyways, we're gonna ignore that. So the division ANS. So the origin is brainstem. And spinal cord. Okay, so number of neurons. We have the pre-ganglionic neuron and the post-ganglionic neuron. So pre and post. And then ganglia. It's near the terminal ganglia, so effector organs. And then we have neurotransmitters. We have both pre-ganglionic and post. They both released acetylcholase. And the types of receptors, we have cholinergic receptors. So we have the I don't know how to spell. I don't know how to pronounce it. It's nicotinic and muscarinic. And the types of receptor. Oh yeah, that's the type of receptor. And then what this does is it rests and digests, meaning heart rate slows down, pupils don't dilate, and yeah. Okay, now for the somatic. Actually, I'm gonna make this. I'm gonna delete this. No, that so doesn't want to go away. Okay, now this. Okay. Okay, so the CNS origin, spinal cord, number of neurons. It's a single neuron. it's a motor neuron. And then location of ganglia, none. Or no location. And then neurotransmitters, we have acetylcholine. And then for types of receptors, we have nicotinic. And then actions controls voluntary movement of skeletal muscles. And yeah, I'm just gonna add another one. Okay, so I also wanted to talk about the cholinergic receptors. So types, we have nicotinic and I don't know how to spell it, the muscle one. And then so the nicotinic receptors, they're found in the postganglionic neurons, both sympathetic and parasympathetic systems, and in the neuromuscular junction. So nicotinic 1 is in neuromuscular junction, and nicotinic 2 is in ANS. And it causes depolarization. The muscarinic receptors, they're located on the parasympathetic effectors and some sweat glands in the sympathetic system. So we have M1 to M5. And it also could cause depolarization or hyperpolarization. And then we have the adrenergic receptors. So types, we have alpha and beta. So alpha 1, 2, and then beta 1 to 3. So alpha 1 causes muscles to contract. Alpha 2 neurotransmitters. Are released, and then beta 1 increases heart rate. And then beta 2 muscle relaxation. And then beta 3 it's a stimulatory involve lipolysis. And that was the breakdown of the question. So yeah, this is what happens. This is basically what happens when a neurotransmitter binds to one of these receptors. And so we'll have a small cell contraction, or and so yeah. And I think that's it.